Hi everybody, this is Mrs. Ellsworth. We're going to be talking about a couple of different problems, actually 3 of them I want to go over, and we're going to be talking about Newton's second law of motion. In Newton's second law of motion, we were given this formula, force equals mass times acceleration. It can be manipulated 2 other ways, where you're solving for mass, so it's mass equals force divided by acceleration, and finally, if you're solving for acceleration, it'd be acceleration equals force divided by mass. Now, I just also wanted to remind you something else too, that we've got, is so important that you remember what your units are for things, because this isn't like the motion formulas where you could figure out what your formula was going to be at the end, because what is a Newton? A Newton is accelerating a 1 kilogram mass 1 meter per second squared. So it's not just always easy to see where these units are and what they look like. So I just make sure that I always have that information handy. Of course, you are able to use, information at home, so keep it handy. Okay, so we've got a little girl that pushes a sled with her dog on it. So the mass of the dog and the sled together is 45 kilograms. The sled accelerates to 0.85 meters per second squared. What is the force? So since it's looking for force, we will take the force equals formula here. There it is. Okay, so let me try with my new pen here. Okay, so we got force equals mass times acceleration. Okay, and let's go ahead. Our mass is right here. Okay, so we've got equals 45 kilograms times the 0.85 meters per second squared. Okay, and when we do that, I have already calculated. When we do that, we actually get a force of 38.25. Remember, you're supposed to always round everything to the nearest 100th. Okay, so what is our unit for force? It is newtons, so we'll just put a capital N there. Now you're going to be also solving some problems online, and so when you do that, make sure that you abbreviate your unit, because then you'll get immediate answers and they'll be correct. I won't have to go back in and correct them for you, so you can get that immediate gratification that you got the problem right, because I'm not writing out the units for the answers to give you feedback on that Google form. Okay, so let's go and reiterate real quick. So this one here is a force equals problem. So we got the formula that's force equals, and then we inserted the mass, and we know that that's the mass because it's got kilograms. Okay, kilograms is a mass unit, right? Okay, so, and then also acceleration, that is a meters per second squared unit. So those kind of help, those units really help me in problem solving. Okay, so let's go and look at another one. I want to look at this one right here. Okay, wait, let me grab this. Okay, a 68 kilogram runner exerts a force of 59 newtons. Okay, do you remember that I said before that they recommend that students go and write out what your givens are, so that mass equals 68 kilograms. Sometimes I do a shortcut and I do that kind of thing. And then, okay, so a 68 kilogram runner exerts a force of 59 newtons. It is force and it is newtons. Okay, so this right here is a force. And they want to know what is the acceleration of the runner. So we need an A equals formula when it says that. So over here we've got, and we do have force and mass provided for us, so this is perfect. So we've got force divided by mass, and that's going to equal 59 newtons divided by 68 kilograms. Okay, and so for that answer, I happen to already have it calculated, so it's going to be 0.87 meters per second squared. Okay, and that is our acceleration unit, so that makes sense there. Okay, when you go and type this into the computer, to go in and put your answers in for the problems, I have answers for, I would have it for 0.87, 0.87. I would have meters per second squared, but you can't have a little 2 there, so it ends up being a big 2 because they don't have superscripts in the Google form. There's no way of using that. Okay. So we've already went through one problem, the first one, that was a force equals problem. This one is an acceleration equal, so of course we're going to look at a mass equals 1. Okay, a sports car accelerates from 0. Oh dear. Let's see if I can get my pen figured out here. Sorry. Oh dear. Okay, well now I can't see my arrow. Oh gee. Ah! Patience, Tamara. Okay, well we're just gonna wing it. Oh, hey, it's working. Okay, it goes from 0 to 60 miles an hour, or this 27. Oh, I can't see where that is. 27 meters per second, and does that all in 6.3 seconds. Okay, so the car then goes and exerts a force of 41.06 newtons. Boy, I'm having troubles here. Anyway, let's keep on going with this. What is the mass of the car? Well, you were given force. Right here, you're given force, okay? And you have to go and calculate up here. You're going to have to calculate the acceleration of that. Okay, so let me figure out something here real quick. Okay, I'm starting all over here. We've got a sports car that goes from 0 to 27 meters per second and does it all in 6.3 seconds. Okay, this looks better because this right here's our time. Okay, and here is our final velocity. Remember that? And here is our initial velocity. So this from the first unit. So with all those right there, we can figure out what our acceleration is. Okay, so we've got force down here. You'll have two problems, one just like this and one that's really similar to it on your problems that I'm going to assign you. Anyway, so we need to find the mass of the car. So that's going to be the m equals force over acceleration. So m equals force over acceleration. So we know what the force is. Let's go ahead and figure out what this acceleration is. So I'm going to do that over here. Okay, so we got a equals final velocity minus initial velocity. Oops, that's a minus. All over time. Okay, and so that's going to be that 27. Don't use a 60 miles per hour because that doesn't even match any of the other units. So it's going to be 27 minus 0, and that's all going to be over 6.3 seconds. Okay, and that right there does equal, I've got this calculated for us, that does equal 4.29 meters per second squared. Okay, so now we'll go take this information down here and we'll go insert into our problem. So I'm going to continue right here. We've got force equaling 41.06 newtons. Okay, we just calculated our acceleration. It is 4.29 meters per second squared. Okay, and so when we calculate that all out, we're going to find that our m is going to equal, I've got that calculator, it's going to, wow, it's a large number. It's 957 point, oh, that's just ugly. 957.11 kilograms. Okay, so that's what our mass will equal. Now, I want you to know that you've got an assignment now with like 10 problems or so on it, and sometimes I'll ask you, which one of these formulas would you use to solve this problem? And I mean like I'm doing here. I know that you could say, honestly, you could say, oh, any of these formulas would help me solve this problem. But I'm looking for that you are able to comprehend that this one's looking for the mass, so this will be the mass equals formula. So when there's 3 questions like that in your notes, so make sure that you're looking at that. And so here are like the choices. If it's choice A, it's because you're looking for force in the problem. If it's choice B, it's because you're looking for mass, and you're given the other 2 variables in there. If you're looking for C, it's choice C, and so that's what you've got for some answers on that. So I hope that makes that clear enough on that. I can't see your work, and I'd really like to be able to see what you're doing. So that's why I've got it set up like that. And so there's like 10 problems or so, I'm not sure, maybe 8. And then I went and put 3 questions about these, asking when would you use those type of situations. And so those are multiple choice. Again, when you're writing in your answers, you type in like 957.11 kilograms. Make sure you round to the nearest hundredth if it's necessary, and don't forget to put kg behind it. Kilograms, you notice all of these units have got lowercase letters except for newtons. Newtons has to be uppercase, so make sure that you don't goof up on that either. So that's all I got for you right now. Make sure you follow the instructions on that worksheet, okay? And I will see you when I see you. And I think this is my last thing that I've got with you online until next week. See ya. Bye-bye.